and we're going to allow a very big divergence. So basically now the particles will inherit some of its parent's speed, only 10%, but we're going to allow the particle to diverge a lot from the direction that the parent was traveling in. And what that will allow you to see is, as the particles are spawned, you'll see the build-up of them much more clearly. So let's start stepping through time again. And you can see this particle has emitted these particles, and it's not really very evident, but you can see we've now got 17 particles in this event. And if I step forward another frame, we've now got 22 particles. And if we step again, we've now got 45, we now have 73, and 99, 155, 212, 399, 466. What's happening is on every integration step, which in this case is just a frame, more particles are being spawned, and the particles that are spawning more particles, and you can see it's producing this kind of bushy effect that you can see here. So if we keep on stepping through, this is not really a big problem at the moment. We've only got 466 particles, it's not really a big issue. But if we keep on stepping through, you can see we're up to 2,200 now, and we keep on going. We're now up to 7,600, and now we're up to 25,000. And you can see it keeps on producing this tree-like structure. And I'll keep on stepping: 34,000, 46,000, 62,000, 83,000, 112,000, 151,000. So you can see we've got now a huge number of particles, and that's because we're not splitting them off on each attempt to the deleting event, and that's what causes the problems. This is what I would describe as being a particle explosion. So it's always a good idea to keep your particles plugged into a deleting event, which will keep them under control, and it will also keep them from contributing to the spawn as well. So just put that back to 10%, and you can see we've got our trails back again. And you can just play and not worry about the particles taking down the system. Now, the second type of spawn is called a collision spawn, and we'll just load up an example file for that. Here we go. And I'll just press play on this. And you can see it's pretty clear what's happening with this particular version of the spawn. It's acting as a combination of a spawn test and a collision test. So if I bring up particle view, you can see what's happening here. You've got a collision spawn, and that's using a U deflector, which is using the sphere as a collision surface, and that is then spawning more particles. And if we have a look at the values here, you can see that when it collides, it spawns on the first collision 100% of particles, and it offsprings 5 particles. So that one particle then becomes 5 particles. You can see it's inherited the speed of its parent, and it's using a divergence value of 39. This means that the particles scatter off in a random direction. Then what happens is I use another spawn, just a standard spawn, not a collision spawn, and that is then used to produce our particle trails. And you can see I've used this kind of pistachio color to show the particle trails there. I'm also using a standard spawn in the first event, and that's actually being piped off to this deleting event. And in this case they're being displayed as dark blue dots. So you can see that the collision spawn is just like a normal spawn, but it only becomes active when there's a collision. Because of that, it doesn't have the option to spawn based on distance. It only has the option to spawn based on a collision. That's its function after all. So there we go. That shows you what you can do with a collision spawn.